Hey everyone, we are shifting gears on this series. So up until now, I've been talking about function refs in Vue 3 specifically, and the series was called Real World Function Refs in Vue 3 or something like that. I don't know. Super wonky. I wasn't a huge fan of it. I'm renaming the series to Stop Hating Your Code for two reasons. One, it's clickbaity. I think YouTube's going to like it. Number two, I think it is a better description of what I want to talk about more broadly. So I really like function refs in Vue 3. I'm still going to talk about them. They're still going to be maybe like 20% or more of this series because it's, like, in my opinion, the most underrated piece of technology, at least in Vue, if not more broadly in reactivity frameworks in general. But I want to scope out a bit. I want to be able to talk about things like the React equivalent feature, which would be callback refs. And that stuff is super exciting because more so than any other pattern, the function ref composable pattern in Vue translates incredibly well to React. The code changes to transform what you would call a function ref composable in Vue over to what we would call a callback ref hook in React. The amount of work needed to make that translation is so much less than the work that you would have to do to translate a compound component or rewrite an entire Vue render function or a Vue template as a render function in React. There's so much work involved in converting these other patterns, and it's a huge reason why so few people publish code for both Vue and React. I think function ref composables and callback ref hooks in React have a really good chance of changing that trend. So I want to talk about that stuff. I want to be able to get into React. I also want to talk about TypeScript because I think there's like a amount of knowledge that you need to have about TypeScript to be able to write these composables and this kind of more library-oriented code effectively. And I think there's some low-hanging fruit there for things that are really difficult to teach in other courses or in TypeScript documentation that if we dedicate videos to and combine different features and see real world examples of how they'd be used, it's going to make things click a lot better for a lot of people. So that's kind of the main focus. Vue 3 composables, React hooks, and general TypeScript stuff. We're thinking more of like intermediate features to advanced features like generic types, constraining generic types, all that kind of stuff. So, and then occasionally maybe I might talk about best practices for legacy code. So like properly documenting old code that's written in plain JS, maybe with a bunch of jQuery sprinkled around, maybe some like jQuery UI or Bootstrap UI stuff. I think there are still relevant ways to improve the way that you write that code if you write that at work. So that'll be a much smaller portion of the series, but definitely something that we might get into. Anyway, okay, so you've been looking at a static screen for like 2 minutes while I ramble on and talk about nonsense. So let's get into the actual meat of today's video, which is talking about type safety for event listeners. And let's just dive right in. So I've written this little function. It's called once. And this function is designed to run an event listener, attach an event listener to an element, and make sure that event listener only runs one time and then immediately gets removed afterward. So if you've used jQuery, this would be like very inspired by the jQuery.once method. Or if you've used Vue, Vue has something similar. You can put @click.once on an element, and that click handler would only run one time. So this is just kind of a plain JavaScript implementation, or plain TypeScript, I should say, implementation to give us something in TypeScript to play around with. So the signature here is the first argument is an element. We pass in an element, and that's going to be an HTML element or null. This is actually the return type of document.query selector. So if the element is not in the DOM, it would return null. So the idea here would be we'd grab an element with document.query selector, and that's what we'd be passing in as the first parameter to once. Then the second one is name. That should be the name of our event. And then the third parameter is the listener that we want to run when that event happens. So for name and listener, the type signatures, I think, are where things start to get interesting for today's video. So name, we're just typing plainly as a string. It can be any string. And then listener, we're typing as event:any, and it returns void. And this is right where we're going to start to get type unsafety in our app, and things are not going to work nicely, and it's going to be a world of pain anytime we want to maintain or change this code in the future, especially if we're not the original authors of it. So ideally, right, the type of event would match the name that we're using for the event. So if name were click, then event should be a mouse event. If name is keyboard, event should be a keyboard event, and so on and so forth. And you can see down here where I've called once and I've passed in my button and I've passed in click or key down, and then I've passed in my event handler. If I start to hover over stuff, you can see the event, this click event is just getting the any type. It's not type safe at all. If I hover over client X, it should be a number, but it's not detected as a number. If I change client X and do event.key, the key property doesn't exist on mouse events, so this should instantly be a type error and it shouldn't compile. But if we have this event typed as any, this is going to make its way straight to production and it's going to cause production bugs. So ideally, we would have this event be detected as a mouse event somehow, right? There's an awesome solution. It's really nice. It's really cool. It's really fun. But let's first look at maybe a couple ways that people might try and solve this problem on their first pass, I guess. So something that a lot of people might intuitively do is to take this event, and when they use this event, they might just say event as mouse event. And now TypeScript will know that this is a mouse event, and it will know that client X is a number. So that works. That's kind of nice. We can do the same thing here. We can do event as keyboard event, and then our .key property will be detected as a string. And if I try and change client X to key, TypeScript is going to complain and it's not going to let us compile this code. So this is a nice kind of band-aid, a nice quick fix. But what I really hate about this code is that I'm babysitting TypeScript, basically. I'm doing additional work. I'm going out of my way to give TypeScript information that to me is incredibly apparent and obvious. Like as I'm reading this function, which at this point is basically just written in plain JavaScript, I know instantly as a reader. I don't have to have a lot of web dev experience to know instantly, like, okay, this is a click event, so this event is going to be a mouse event. I already know that. I want TypeScript to know that. I don't want to have to give TypeScript additional information manually every time I access this event just to kind of catch TypeScript up with the knowledge that I already have. So yeah, that's kind of like, that's a philosophy that I have about TypeScript very often, is that anytime I feel like I'm babysitting TypeScript, it's a red flag. Something's going wrong. I'm not using the tool properly, because TypeScript is supposed to make your code safer and really ideally should make you write that code faster. Like it should give me autocomplete. So I just have to type like CLI and it will autocomplete as client X. I can just hit tab and it'll complete that property. So I should be able to code faster and more safely with TypeScript help. I shouldn't have to be babysitting the tool to catch it up with knowledge that I already have. So let's look at a slightly different solution. So if I were to come up here to the listener, I could change this event, and maybe I just type this as event, because all events extend from event, right? All mouse events and keyboard events, they all extend from this base event option. But if I just type this as event, then TypeScript is going to think that this is actually only just the plain event object, so it won't have client X, it won't have key, it won't have any of those special properties of other different types of events. So if I do something like mouse event or keyboard event, and I would have to, add a new union type for every possible event that I might want to support. If I try and do that, still we're going to get type errors. The type error in this case, on our mouse event would be property client X does not exist on type mouse event or keyboard event, because client X only exists on mouse event, but this event, according to TypeScript, could potentially be a keyboard event or an event which don't have the client X property. So this also is not going to work. So the solution here is we're going to use some generic types. And really this whole video is just an excuse to talk about generic types, which I think are notoriously difficult to learn and understand in TypeScript. And I think a lot of that is because the real world use cases for generic types are complex enough that you can't include them in documentation without also having to include other TypeScript features that you're not trying to teach in that moment, or without getting lost in implementation details and distracting people with, how they might solve the same problem that you're presenting. So I think, there's a bunch of reasons why generics are difficult to teach. Hopefully, tackling it from this angle where we have a little bit more space to be more flexible with other features that we can talk about and stuff. Hopefully after this, if you've had trouble with generics in the past, they're going to make more sense after we go through this example. So first thing I want to do is set up this once function, and I'm going to set it up with a generic. I'm going to use that generic to detect the name of this function. So I'm going to set this up as name. We can say name extends string. So this would be called constraining the generic. I could also just set this as name. And then I could set name to that name type. We're going to get some type errors here. You can ignore that for now. But let's just say I type it like this. I create my generic name type. Side note, by the way, I cannot stand when people just use single letters for this stuff. I think that's like 80% of the reason why generics are confusing for people is because the convention is to be totally non-descriptive with your names that you're using for generic types. So my advice to you is always use actual human readable names for generic types. No pun intended right now because ours is actually called name. But yeah, use words, use real world words, not single letters, and I think the code will make a lot more sense, not only to you, but also to other people who read it. So anyway, if we scroll down here and we hover over once, now we've got some interesting stuff happening. So the name, we've passed in click as the name. Once clearly is detecting that name is a string. And you can see it's filling in this generic thing with the string. But that is not quite good enough for our purposes. We want this to actually be detected as a click event because we want TypeScript to know that it's a click event so that hopefully it can figure out that click events correspond with mouse events, and we can make that connection. So right now, detecting this as a string is interesting, but it's not quite good enough. It gets a little bit more interesting if we do name extends string. Now we can hover over once and we can see actually that is detected directly as click, as the constant type, the exact word click. So that's kind of cool. And if you look down here, it also happens with key down. So that's good. It feels like we're getting a little bit closer. But what we really want to do here is actually not have name extend any possible string, because then we could just pass in like whatever here, and that's not a real event type, and it would type check just fine, and we don't really want that in this case. So what we're going to do instead is we're going to do name extends, and then we're going to do something cool here. We're going to do key of, if I can type, key of HTML element event map. And so two things going on here. One, the key of keyword, and two, this HTML element event map thing. Let's take a look at this one first because I think it's going to make key of easier to understand if you haven't seen that before. But I'm going to alt-click through to this. This is a built-in type, by the way. It ships with TypeScript, so you'll have it in VS Code. It would be in lib.dom.d.ts. Yeah, this is a browser web API thing. It ships with TypeScript to support different web APIs. It's an interface, which is kind of like an object, but in TypeScript. And this particular interface extends 3 other interfaces. And that means basically that it combines all the properties from these 3 interfaces into one thing. And the one that we're concerned about right now from the source is we're concerned about this global event handlers event map. And this is really cool. So this is a built-in, basically an object that maps every single possible event name to the actual event type that corresponds with it. So if we find click here, you can see click corresponds to mouse event. And what we're going to try and do is get TypeScript to take our event type, which we're detecting, in the one, if we hover over once, you can see we're detecting that this event type is click. So TypeScript knows, okay, we're dealing with something related to a click here. So we're going to try and get TypeScript to look up click in this interface and retrieve the mouse event type. So look up the event, retrieve the corresponding event type. The way that we're going to do that is by using our generic type and using it in our listener type. Instead of doing event : any, we're going to do event : HTML element event map square brackets and then paste in our generic type. So HTML element event map, looking up the name, retrieving the event type that corresponds with whatever name is. which in our case is this generic type that we assign to name. So if you notice right away, we're actually going to, yeah, it's already working. So we're going to get this event detection on our event. So parameter event is a mouse event. And if I scroll down here and hover, event is keyboard event. So that's working. But let's break it a little bit again to just kind of explore the concept a little bit more and talk more about it. So I'm going to remove this extends key of HTML element map thing, and we're going to see what happens. So if name can technically be any type, we would not be able to detect the name of this thing. So even though we're passing in click, and in theory, click should then be set as the type of name for our generic, TypeScript should infer that. It's still not going to work because it's being detected as string. And if we try and look up any old string in the HTML element event map object or interface, it's going to tell us type name cannot be used to index type HTML element event map. That basically means that whatever name is, it potentially could be something that is not one of the keys, not one of the keys of this interface. It could be, again, just like whatever keyboard mash, which of course is not possible. We can't look up that string on this object, on this interface, because it doesn't exist. So yeah, if we do name extends string, that still is not quite going to be good enough. Our other type errors at runtime are going to go away, but internally inside this function, we're still going to get a type error on the function, on the type signature of listener, and it's going to be the same thing. Type name cannot be used to index type HTML element event map. Same issue. This could be, even though this is a string, it could be any possible string. According to TypeScript, it doesn't necessarily have to be one of the strings that exist on this interface as one of the keys. So yeah, to narrow that down and make sure that TypeScript knows exactly which strings this could potentially be, we do key of HTML element event map. And now TypeScript knows, okay, so this name generic, once it's going to try and figure out what this is. It's going to try and infer what this name generic is. And it's going to do that by reading the name parameter that we pass in. And we'll talk a little bit about that type inference and how that works and how to think about it. But yeah, just to reiterate this, it's looking up, it's figuring out what name is. It's asserting that whatever name is, it has to be one of the keys of this HTML element event map interface. And then once all those checks are done and we're satisfied with all that, then we can go into this interface and look up the name and retrieve the proper event type. And get proper type checking on our event. So if I try and do event.key on my click handler, you can see property key does not exist on type mouse event. That's good. That's exactly what we want. Because if somebody, comes back to this event handler in the future and maybe decides to do like a key down, switch this event, we want them to be able to get these type errors in their IDE and at compile time, so that they remember to update all the other code that might be in this event listener, to make sure that it's up to date and that it's working with the right kind of data and it's not going to cause runtime errors. So back to this concept of generics, right? Generics, I think another thing that confuses people about generics is because they do the opposite of what we did today. Today we wrote plain JavaScript, basically, and then wrote some fancy TypeScript so that behind the scenes, TypeScript is inferring the types. It's reading the code that we write and inferring the type of different things and then using those type inferences to make assertions about other types. So it's inferring that name is click. And now that it has inferred that piece of information, and it can assert that the event here is a mouse event. So inferences and assertions. TypeScript is really, really good at those two things when we wire it up to do that properly. I think what a lot of people do with generics is they'll start with nothing here. We'll just comment this code out as if it's not existing yet. And they'll pass in a generic. So they'll do once and they'll do angle brackets and they'll type in click. And then again, they'll come down here and type click and do it this way. So I think maybe if we do name extend string, I think at runtime, yeah. So you can see in our function, this is not type checking properly in the signature, but at runtime, since we've specifically passed the constant click into here, this is type checking properly at runtime. So still not good because our internals are not working the way we need them to. And we could do stuff like, we could do other things to basically disable this error from happening. But at the end of the day, what we've gotten back to here, if you take this approach with generics where you're manually passing in the type of the generic that it's supposed to be, you've gotten back to a place where you are babysitting TypeScript to give it information that it should already have, that is already very obvious and apparent to you as the code author or the code reader. And that is, I think, what makes people hate TypeScript, is that they feel like they have to babysit it all the time and give it this information that's incredibly obvious. And it's just annoying and repetitive when you have to do that when you're building an entire application. So, yeah, what we want to avoid always, at all costs, if at all possible, is never pass types into generics manually. And really, at the end of the day, the goal is write plain JavaScript and have it magically work. Have it magically throw errors for stuff that you might have missed. Make sure that it's checking your types and preventing silly bugs or silly mistakes. But your code, as often as possible, should look like plain JavaScript, because that's going to be the most efficient type of code for you to write day to day. If you're sitting around writing type annotations all day, that's just losing time that you could be using to do code maintenance or get rid of tech debt or build a new feature or improve accessibility or other stuff like that. So the time that we spend babysitting TypeScript takes away from that other really valuable time. So as often as possible, keep that in mind. Try to write plain JavaScript. Write it first. If it helps, write the plain JavaScript usage in userland code first, and then work your way backwards through TypeScript to try and make things type check properly. And I'll put this all back in place so it works again. So yeah, there's our once function. I guess we can quickly go through the internal implementation too. We define this once listener, and then that accepts an event. It runs the listener that we passed in as the parameter, and then instantly after that, it removes the event listener. References itself, which I think is a little trippy. This self-referencing stuff can be kind of difficult sometimes, but this is I think kind of a normal implementation of a function like this. And then once we have that handler defined, we can say element.add event listener, pass in the name, and pass in our once listener, which of course will just run one time and remove itself automatically. So yeah, there we have it. Event listeners in TypeScript with type safety. You can build these custom little wrappers around event handlers now and do different cool, interesting stuff with them without losing type safety, without losing autocomplete, and without forcing yourself to do additional work to make TypeScript understand what is already obvious and apparent to you as the author or the reader. So yes, stop hating your code, stop hating your event listeners. Generics, generic constraints, the keyof operator. We covered a lot of cool little TypeScript features in here. Hopefully seeing all of these things used in combination and hearing a little bit more about like the philosophy of how I think about how TypeScript should be used. Hopefully that makes these features make a bit more sense to you if they haven't made sense before. I think generics are kind of challenging until you start to wrap your head around this basic flow of like first step one is to infer the generic. The purpose of the generic is to let TypeScript infer something, and then after that make the assertion. So first you infer the type, and then TypeScript can make the assertion about the type of something else. So there's always that kind of like two-way, two-step flow, information going into TypeScript and then information flowing back out of TypeScript. So that's kind of the abstract purpose of generics. That's the way that I use them when I am writing code, and hopefully that makes it make a bit more sense to you if it hasn't before. So yeah, I will see you in the next episode. I'm going to be doing a bunch of this stuff. I think scoping this series out, talking a little bit more broadly about not just Vue, but also React and TypeScript, and maybe even a little bit of legacy jQuery Bootstrap stuff. It's given me a good amount of energy to come up with more content. So I'm excited about that, and I will see you in a future video.